Good morning, all of you. Shobha, let us start, Shobha.
Okay, ma'am. A very good morning to you all. I welcome you all for the day 3 session in the Faculty Development Program on Thrust Areas of Research in Civil Engineering. On behalf of Department of Civil Engineering, I welcome today's speaker, Dr. N.G.P, Associate Professor, Department of Civil Engineering, Konga Engineering College, Perundurai. I feel it as a great pleasure to introduce the speaker, Dr. N.G.P. I feel it is a great pleasure to introduce the speaker, Dr. N.G.P. She has more than 12 years of teaching experience. She has published over 35 papers in reputed journals and presented 16 papers in national conferences and 12 papers in international conferences. Ma'am has received Best Faculty Award in the year 2016, Best Mentor Award during the year 2017, and Best Citizen of India Gold Medal Award. She has delivered a number of seminars and guest lectures in the areas related to concrete technology and waste management. She is a member in Institution of Engineers India and Indian Society for Technical Education. Ma'am, we are very happy to have you with us. Thank you for accepting our invitation and being a speaker today. Kindly take over the session, ma'am.
Thank you, Shobna. And first of all, I would like to thank the management of Dr.N.G.P. IT, Muthupriya ma'am, and my dear student Shobna for inviting me for this 5 days faculty development program on trust areas in civil engineering. So my gratefulness to Muthupriya ma'am once again. So with this, we can get into today's content. Hope my screen and audio is clear to everybody.
Yes, ma'am.
Yeah. So getting into today's content, I have planned the session in such a way that some interdisciplinary approaches in the field of civil engineering can be discussed today. So far on the day 1 and day 2, we have seen the research areas related to concrete and geotechnical engineering, that is soil mechanics study. So here we go with some interdisciplinary approaches. What is the need of the art for research in civil engineering? When the topic goes like trust areas in civil engineering, I would like to throw some lights on the recent areas or the real pressurized areas where we have to focus to. So the content today has been planned in such a way that what we have did in research, what we are doing in research, and what we have to do in research. This is how the content of today's ONA presentation is planned,
Ambika, please,
especially, ma'am.
please give a slideshow, Ambika.
Is it okay now, ma'am?
Yes, no. Okay, okay.
Okay. So we are going to see what is the researches carried out so far and what is the research we are doing at present and what is the need for the research and innovation henceforth. That is in forthcoming days, what is the need of the art. So what we actually did in research is all some replacement. Example, we can say take the area of concrete technology. As I belong to construction engineering management stream and I was focused on concrete technology in my research, I would like to throw some glimpse over the areas where we have focused the research of civil engineering especially. That is studies on the efficiency of eco-friendly concrete, study on strength and durability aspects of steel stack concrete, effect of coconut shells as aggregate in self-consolidating concrete, and again mechanical and durability aspects of basalt fiber reinforced concrete. So these examples or these are the some of the researches what we have did in our age. That is, we go for some replacements. As concrete is very much blooming in civil engineering, or materials has a very good part in civil engineering, we focus only on the materials and later into the composition of materials like concrete. The matrix of concrete has been replaced with several materials, either the available materials or the unavailable materials. So we gone for replacement, and that replacement contributes more to the research in the early stages. So here are the examples where we have replaced the natural material and the artificial material for making concrete composition. And later what we did, we get into more specializations. Like as we know, we have different specializations in civil engineering. So based upon our domain and our PG specialization, we get into some topics which has a very good voice in the market, like focusing on new materials like geopolymer concrete or basalt fiber concrete, nanomaterials, etc. And instead of static analysis, we get into nonlinear dynamic analysis and the health monitoring of structures. The lifestyle structures are very much important. So there we focused on structural health monitoring of structures using piezoelectric sensors. And we optimize the structure. We have optimized for the material design, for cost effectiveness, for improving the efficiency of the structure, etc., etc. So when we went for optimization with several numerical optimization techniques, and also we focused on seismic resistant designs like elevated water tanks, building chimneys, that is tall structures, tall buildings. But whether they use a technology what is very much recent for all these types of tall buildings and structural optimization means, we can discuss in the forthcoming slides. Environmental engineering. So in environmental engineering, what you are focusing? We are focusing on the air quality monitoring and modeling, risk assessments, solid waste management, emission inventories, and climate policy analysis. These are the focused areas when we get into environmental engineering stream. Because as we know that the emissions of air pollutants are very much rich and high only in industries. I would like to quote some examples or case studies what we have done as a project and given to our PG and UG students. So what we did here is the example where we focused on the Sipcot industry, which is at Perundurai. You know that Sipcot has many small scale industries and it is very much rich in polluting the environment, whether the glass industry or the paint industry or chemical industry, whatever it is, the pollutants coming out from those Sipcots really pollutes the air, and there is a rich emission of all the gases like sulfur dioxide, oxides of nitrogen, volatile organic compounds, carbon monoxide, and TPM. So what we did, we have taken the project to analyze what is the particulate matter relieved from the tannery industry especially. We have a lot of industries in Sipcot, but we focus on the tannery industry, which emits more amounts of particulate matter. So we have used respirable dust sampler and the fine particulate sampler, which reads accurately the particulate matter of 2.5 microns and 10 microns. You may be all aware of the PM particulate matter, that is the mask what we use as N95 for COVID really arrests the particulate matter less than 2.5 microns. So that is what everyone is insisting to wear, only the N95 mask other than the cloth mask or the other material made masks. So we focus on analyzing the amount of emission from the tannery industry, and we calculate what is the particulate matter which is less than 2.5 micron and which is less than 10 micron, by using all the respiratory dust samplers and fine particulate samplers. So we are focusing on these areas in environmental engineering. And here is the example. So we have taken the SIPCOT as a study area for this environmental engineering domain. Hydraulic engineering. Yeah, in hydraulic engineering, we can do some flood forecasting. We are doing flood forecasting and the applications of GIS, Geographical Information System, and remote sensing applications in water resources, groundwater hydrology and hydrologic modeling can be done. So for this, I got an example of Neyveli, that is Kudlur district. We have taken the study area of Kudlur district, and we are into analyze the groundwater strata. As you all know, Neyveli, Kudlur is a very hot, arid region, very hot climate. They have a very hot climate. So all because of the hot climate, they are suffering from the demand of good potable water. So that is a study. We have given a project for the student to analyze the groundwater. What is the level of groundwater by using GIS in Kudlur district. So by analyzing it, we can suggest the municipality or the corporation in order to supply more amount of municipality water or corporation water. So that is what the thing we have planned for this particular project in the domain of hydraulic engineering. Geotechnical engineering. So all these ground improvement technique, static and dynamic soil structure interaction, geotechnical earthquake engineering, numerical modeling on soil structure interaction, analysis and design of foundation. So yesterday, Sandra ma'am was talking more about the research, what has been carried out in the domain of soil mechanics or foundation, and the software what you are using for designing of foundation, and the usage of coarse aggregate and fine aggregate replacements. So this is the areas where we can focus on geotechnical engineering. So since many of things have been discussed earlier, I don't want to stress more on this. Next is transportation engineering. The next domain, the very important domain what is to be considered these days in civil engineering is transportation engineering. So in transportation engineering, we have many areas or many topics to do with, and we are most integrated to integrated transportation system, pavement material characterization, whatever it is, whether it is in bitumen or the other types of materials what we use, which includes even the plastic roads, which is again the latest technology, pavement design, analysis, evaluation and management, traffic flow analysis and highway capacity, safety accident analysis, transport and traffic modeling, intelligent transport systems, what is needed for smart city. So intelligent transport system has been planned and designed for E-Road and Salem City, and we also had a case study. We are given a project for our student in the area of intelligent transport system and the traffic flow analysis, urban transportation planning. So to quote few examples for this safety accident analysis and traffic flow analysis, we have given a project to analyze the accident statistics, especially in metro or rail construction. So we have this senses like the accidents, the fatal accidents, what happens to be occurred in metro rail station is very high and risky compared to the normal land transportation or the air transportation or water transportation. So here I quote the example of the Delhi Metro. So we have given a project to analyze and to overcome the accidents happening in metro rail construction. Metro rail construction. It is not during the movement of trains, but during the construction of metro rails. This accident statistics shows the fatalities happening in the industry. So up to 2012, you may see the fluctuations happening, and the red line shows the tunnel construction industry. It is happening year by year, and as the nation is developing, we go for more number of metro rail projects, and as the number of projects are increasing, the fatalities also increase. The fatalities also increase. So what I have done, we had a study on analysis on the accident status and how to overcome it, or at least how to detect the problems or the difficulties what you are facing in the metro rail construction projects. So there comes the usage of sensors. All these are different types of light emitting sensors, simply called as the OSV. That is optimal signal visualization. So these sensors, what they do, they just sense and track the problems or the difficulties what is happening in the metro rails. When we are constructing underground projects, especially for metro rails, we often come with more sort of fatalities or more sort of injuries. So these light emitting sensors with the capacity of detecting the problems will track, and we can connect this with the station, and the station master can immediately send a signal to the people who is working in, and we can reduce the probability of occurrence of accidents or any injuries or fatalities, or sometimes even the death. Next is the area of geomatics. So very similar to hydraulic engineering, we were using the GIS both in all hydraulic engineering, flood forecasting, and also in the area of geomatics. So here we have the Salem District. As I was mentioning in transportation engineering stream, we have taken the study area as a Salem District in order to analyze the traffic flow for a bridge construction. So as we all aware, the people, the participants from Tamil Nadu will be very much aware that Salem is the 5th largest city in Tamil Nadu, carrying 124 kilometers, and being the 1st largest agglomeration state by population, we are in need of bridging the population to the traffic flow. So as the population increases, there is a demand for roads because of increase in population of vehicles. So what we did, here is the case study where we go for studying the traffic flow analysis and determining the demand for population of vehicles by PCE and PCU. So by analyzing the passenger car equivalent and unit by using GIS, that is Geographical Information System, we will predict what is the amount of vehicles in demand and the need for bridge construction. So again, we are going to suggest this to the municipality or corporation of the Salem District. And Salem District is full of bridge construction. As you all know, our the CM has furnished Salem with all sort of facilities, all sort of infrastructure facilities. In addition to that, We are going to bridge the small gaps what is there between the population of people and population of vehicle. So the traffic flow analysis is studied by using geographical information system. And the last very important area is construction in technology and management. See, we do have construction engineering and management. We also have construction technology and management. Why is difference? What is construction engineering and management, and why now it is construction technology and management? See, wherever we go, whatever we see, whatever we do, we make a technology to be put forth into our engineering stream. Whatever we do, wherever we go, we are very much fond and very much keen to implement the technology into our engineering. And when we say technology, it is all the implications. It is not only the analysis what we have in 2 dimensions like engineering, but we start to get into technology which is defined to be the 3D, the 3-dimension. So that has construction management, building information modeling, sustainable construction technology, and lean construction. So we may all aware, and we have some useful information related to sustainable construction technology, because yesterday ma'am was talking about the sustainable ground improvement techniques or sustainable aspects in ground improvement technique. And the sustainability is the need of the hour. Sustainability is the need of the hour. So as we all know, sustainability is nothing but we are making something, or we are saving something for our future, for our next generation, for our kids, for our grandkids. We are molding our environment or surrounding in order to be more sustainable. That is without depleting the natural resources, without the degradation of natural resources. We are saving something of our future generation, and that is nothing but sustainable construction technology. And how can we achieve that? BIM, a very blooming technology in all fields, not only in civil engineering, not only in construction applications, not only in construction industry. BIM is applicable for all sort of industries, all sort of applications. So what is that? We are in 2 dimensions, studying everything in paper, reading, analysis, reporting, documentation, everything in 2 dimensions. 3 dimension is nothing but the visual representation what we do, and we are all experience 3 dimensions when we get into theaters, or when we get into some animated movies. Then we have experienced what is the effect of 3 dimensions. Or simply we can say that 3 dimensions is nothing but the geometrical aspects, all x, y, z coordinates. The object is visualized as an object, not as a plan. That is 3 dimensions. And 4th dimension, what we are into now, we are just stepping. See, we have crawled, we have stood up, we are stepping, we are walking now, but we are in need to run. We have to run in order to meet the technology or mesh up with the technology. See, it is not that we have to catch the technology these days. We have to mesh up with the technology, whatever we do in our research areas. So 4th dimension of building information modeling is simply said to be the time. Simply the time. So when I talk about time, is it not oriented with the cost? Yeah, it is oriented with the cost, because time, cost, and quality has a very good golden triangle system, which is always dependent on one other. If time is increasing obviously cost will be increasing. If time and cost are increasing, then quality will be achieved very much high. And that is what we have the triangular, golden triangle system. So in 4 dimensions, what we do in order to keep up the time or maintain the time is we go for some scheduling approaches like critical path technique or line of balance method, whatever it is. We have different scheduling techniques, and we also have some advanced scheduling techniques like fuzzy logic, heuristic approach, algorithms, simulation, etc., etc. So all these scheduling approaches or scheduling techniques are taken into account in order to maintain the timeline of the project. If the timeline of the project is maintained, then definitely the cost will be reduced. And our motto, being a construction people or a construction manager or a civil engineer, our motto is to finish the project in stipulated time and budget. So, 4th dimension is very much needed. And what is this 5th dimension? 5D. Purely money or cost. It is all related to the quantity takeoffs, what we do in our estimation software like CostX or other estimation softwares. We can very easily predict the plannings or the clashes, what is happening, or the backlogs, all because of this 5th dimension. And the planning of cost can be very effective in this 5th dimension. So productive takeoffs can be done, and all the estimation softwares can be beaten up when you go for this BIM in order to predict what is the amount we have to install or we have to invest on a particular project. 6th dimension. 60 is all about the environment or economy, or the main thing what you are talking about, sustainability. Simply the sustainability. Whatever the project we do, as we are discussing, it should be sustainable. So in order to make a project sustainable or any product sustainable, it should not degrade any of the natural resources. The prevention of natural resource degradation or the balance what we maintain in our ecology or ecosystem is termed to be your 6th dimension. And the sustainability can be achieved by 6th dimension. Okay. Social representation, the geometry, time, money, sustainability, everything can be achieved. So what is the 7th dimension and 8th dimension is all about? We haven't get into. See, still we are working only up to 5th dimension. So we are in need to run in order to catch the 6th dimension, 7th dimension and 8th dimension. So what do you have to do? 7th dimension is nothing about facility management. What is this facility management is all about? In order to complete the project in time, in budget, with ecology, then we need some information related to facility management. What are the facilities we are in need of? That can be tracked or that can be taken from this 7th dimension. What is the 8th dimension? The very important thing, health and safety. So the health monitoring of structures is not only important, we are in need of safety and health monitoring of the resources. The resources may be the personal resource or the materialistic resource. So we have to maintain the eighth dimension, and the safety and health of these resources can be achieved by this eighth dimension. But are we using building information modeling? We know these are the advantages, and we know what are the techniques, latest technology has been developed, and we are lagging somewhere. Why that lagging happens? See, there is some limitations in using this building information model. Even though it has numerous number of advantages, it is more efficient. It is far away from our imagination. Whatever we are imagine, now we are getting that as a product. But we are not getting into the real content of BIM. See, totally in South India, especially in Tamil Nadu, we have only one BIM related project in Coimbatore. To be true, to be more factual, there were 46 projects in and around South India where they use the building information modeling for projects. But we in our zone are very much lagging in using of BIM. Why that happens? It may be because of the lack of training about building information modeling, which can be improved by attending these types of webinars, or which can be achieved by utilizing this login effectively. The lack of interconnections with the data, that is, the data cannot be connected towards the exact dimension. In which dimension you have to put this data. There is no clear idea about the data collection and where we have to implement this data. Workflow adjustments. Yeah. It needs some workflow adjustments, but we are lacking in workflow adjustments, and there is no realistic methods and norms. There is no realistic methods and norms for BIM applications. Our habit of opposing towards any sort of new technique or any sort of new things, and it is a little bit costly because of its efficiency and speed. It is a little bit costly, and we do have some contractual workplace. Lack of awareness and encouragement from the management. If you're working in a company, if you're very much able to work with BIM, but there is some less motivation from the management side, so you don't have any supports. Accessibility of BIM tools. Whatever the software you need for estimation or for designing or for analysis, the tools may be insufficient. Construction information security and reliability. Missing system of insurance for BIM application. Effective management of data. And does not having a very good experience of BIM technology because it is booming these days, but not into the existence picture. So there is no guidelines, no proper way of awareness, and all because of these things we have some lack of coordination from stakeholders. It may be employee, it may be the people who is working with, or the feedbacks what we get is not that much positive. So we are not using this BIM technology as like we are into our past stages, like replacing of materials in the concrete, or what is it, getting into different sort of specializations and working in the research areas. But actually what we have to do means it is not enough to stop with only the research. We have to combine the research with that of invention. When we talk about invention, I remember a quote that there is no nation without invention. There is no nation without invention. Every nation is developing either by GDP or by infrastructure or by resources, all because of invention. So what is this invention is all about? Invention is something making your ideas into a product. Very simple. Whatever idea you get, you just implement it to take it as a product, to come out as a product. And that product, when you market it, when you take to the market, then definitely that makes you money. That gives you money. So invention, one or the other way, brings you the financial support. So this invention has to be combined with research in order to meet the coming up technology. So what I have did so far, we have been finding a solution for the problem. We are running behind a solution for the problem. But how invention develops? How can we invent things? How can we make a product? How can we market that product? How can we monetize that particular product? Means all because of running behind the problem and not behind a solution. And what is this now? How can we run behind the problem? See, once you run behind the problem, then there comes the solution for that particular thing. And that solution is nothing but the invention. Invention is nothing but when we run behind the problem, then definitely we could get into some simple ideas which can make it into product. For example, when we are designing some cycle rickshaw, when we a simple cycle rickshaw. See, if it has two pedals, it is a normal plan or design of cycle rickshaw. But all because of the constraints what the cyclist, the rickshaw man have, if you're putting 4 pedals instead of 2 pedals, then that becomes a simple invention. Very simple invention, which really meets the demand of that particular rickshaw man. So we have some different approaches where we have to measure with the technology, and here are the little glimpse of the recent approaches, what we have to do and where we have to focus on. We can see one by one. So maglev. So maglev is nothing but the magnetic levitation. It is all the magnetic field what is surrounded, and because of that magnetic field, we design the trains. We design the trains. So as you all aware, in Japan, China, we have the very fastest train moving. Especially you can see these sort of very luxury and sophisticated trains which moves very fast. So what does this do? It is all because of the repulsion of the magnets. We have two magnets on the rails of the train or track, and because of the repulsion, same poles reflect and unlike poles attract. So because of that reflection, what happens? The train starts to move very fast. It is all because of the magnetic field what is surrounded, the pushing effect. Because of the same pole's repulsion, the tracks are very much aligned and the object, the train, moves very fast. It is all because of the fast moving. When the velocity is high, then definitely the density of the object starts to reduce. So it is all like a very simple example of the ball what we play in our childhood days. When we blow the air into the pipe, the ball on the pipe will starts to float, starts to fly in the air. And based upon the air what we blow, it is all based upon that air, the ball stands on the air. You might have experienced that. Very simple technology in this side of maglev train. That is all because of the magnetic field surrounded in the tracks and same force pushing effect. The train moves very fast. The train moves very fast. Yeah, and it all happens in Japan, South Korea, and China with the fastest speed of 431 kilometers per hour. See, we may experience the bullet trains and we may experience the flights, which is the very fastest mode of transportation, but these magnetic levitation oriented trains are the world's fastest train with a 431 kilometers per hour. So we have implemented this magnetic levitation as a project. So what we did, we have framed a little doll, okay, which is levitated by the magnetic field. What we created, we have created a miniature, and we are trying it in our laboratory. So we are trying to implement this for our small products. The fastest train in Shanghai. Next is Hyperloop. The next technique or the next approach what we talk about or what we are in need is Hyperloop. When we talk about loop, Hyperloop, it is all the capsule where we travel inside the capsule. Hyperloop is the one which is a chamber connected to the capsule. So it has been implemented in Mumbai, and that is what I have shown here. So we have experienced the train which is underground and which is also overheader. But this is like we will be traveling only in the capsule, and later after we get out of the train, we can see the sceneries outside or what are the stations are above. So this is the current technology. It is a little bit costly, very costly, and for information, IITM has signed up with the collaboration. India has been collaborated with IITM for this sort of implementation along with US. It was implemented initially in US, and the steps have been taken out along with IITM for this land transportation system. Very simple, the capsule travels. This is how the Hyperloop will look into it. We will be traveling in the tunnel like or the capsule, and this is how it looks like. Next is Kinetic Footfall. So this has been implemented all over the countries abroad, and we are trying to. It is all the observing of our energy from our footprints. When we walk in our pathways or pedestrian walks or wherever we have some lot of apartments or pathways or in metro stations, it is all simply the conversion. It is all the pressure transducer. That is the conversion of one energy to the other energy. Our mechanical energy, the mechanical energy what we pressured by using our food is converted into electrical energy. It is very well implemented in all countries like China, Singapore, US, everywhere. Wherever we have more apartments and wherever the population is very much dense, they just have the setup like these things. to capture the energy, to absorb the energy when we keep our footprints over this. This is how it looks like. When we give pressure over here, our mechanical energy is converted into electrical energy and is saved. And this electrical energy can be used for lighting in the parkways or undercarriage system or subways or for parking areas, etc. etc. We generally call this as the footfall harvesting. So this has been implemented and we have tried this again in our college. But due to the feasibility condition, we couldn't observe the electrical energy as such because we need some hard data. The spongy areas will not be very much effective for these sort of observations of energy. We need some hard areas and we have to connect all these sort of transmitters and receivers in order to convert one energy to the other energy. The amount what we are going to spend is only less because we use only the transmitters and receivers as we do for our USPV test. We should have some receiver and transmitter, but we need some plenty of receivers and transmitters in order to collect the electrical energy and store it. So all because of this feasibility, we couldn't succeed in this particular kinetic footfall technology. Yeah. Photovoltaic glaze. This you may heard of, and we are working into a very simple technology where we apply the photosynthesis principle. Or simply we call this as the advanced solar technique. That is, the efficiency of natural lighting, that is the sunlight is improved by this sort of photovoltaic glaze. We improvise the efficiency of sunlight by the principle of photosynthesis and we convert that into energy. A very simple mechanism of photosynthesis is what we studied in our physics. So we have to create a solar panel which receives the natural light and that has been converted to develop or generate thermal energy which can be used for other purposes. A very simple technique in the solar panels what we observe, the same technique is adopted with an advanced system. And for this, we have tried a project by placing the solar panels in the side walls of the building. See, often we go for placing the solar panels in the rooftop because we receive the sunlight very efficient only in the top of the roof. So we always go for placing the solar panels in the roof system. But we have tried what happens when the sun comes down, what happened to the emissions or what happened to the absorption of sunlight in the side walls of the building. So we have tried by attaching the solar panels in the side walls of the building and we are into collect what is the amount of natural light we get from the side walls of the building and we are trying to implement that for improving the thermal energy. So here is an attempt to implement the photovoltaic glaze in order to measure with the recent technology. And coming back to our own area, self-healing concrete. All will be aware of this word, self-healing concrete or simply the bacterial concrete, which is a new type of concrete, but it was in existence. But we have a very strong feeling that this self-healing concrete will improve the strength of the structure. We all have a very blind concept that the self-healing concrete improves the strength or the strength enhancement of the building or material is improved with this self-healing concrete. But self-healing concrete will never improve the strength enhancement, but it improves the lifetime of the structure. The span of the building or the effective life of the building is improved by using the self-healing concrete. So what does self-healing concrete do? We just introduce the bacteria. The bacteria may be the Bacillus pasteurii or E. coli or Subtilis, any kind of bacteria. And we are into only these three types of bacteria. And the developments or the research can be done based on findings of the new bacteria other than the Subtilis or E. coli or pasteurii. So what we did, again we go with the case study. For reducing the pores in the concrete, we have bought a dose, that is stains from Chandigarh, that is from a microbial type culture center from Chandigarh, and we have cultured it. The one stain or the one drop produces some 10 to the power of minus 25 cells. You can imagine the size of the cell, 10 to the power of minus 25. So that one stain can develop multi-culture. We can do multi-culture in that one stain. The stain will be like a capsule, like a drop. The drop will be like a capsule. And that bacteria will heal the pores or the cracks what is induced in the buildings. And it's all because of arresting the micro cracks or the hairline cracks in the buildings, or because of its saliva secretion, or because of the lactate, that is the calcium carbonate secreted from the saliva of the bacteria. The concrete will be free from the hairline cracks or the micro cracks, and all because of arrest of the pores and the hairline cracks. The lifetime of the structure, the lifetime of the building is very well improved, and the growth can be seen very clear under the microscope in self-healing concrete. The failure mechanism will be postponed when you go for this type of bacterial concrete, and the lifetime of the structure will be very well improved. But all other parameters like consolidation or compaction or curing, formwork removal, everything should be done as per the norms, as per the standards. Whether it is an aerobic or anaerobic bacteria, then definitely all the other parameters like consolidation, compaction has to be done as such. And this is a very, very simple way of arresting the cracks or sealing the pores of the structure or buildings. Next is all about 3D printing and 3D scan. Here we go with the 3D printing. So you can see the 3D printing over here. This is 3D printing, and this is the object what we have made of 3D printing, a board, and here is 3D scanner. So 3D printing is again the latest technology what we are working with these days, or we simply call it as the digital printing. And this is the portable 3D printer what we have in our college. So this is very much blooming in construction industry, but it has been already existing in manufacturing industry or automobile industry or mechanical industry everywhere. In construction industry, it is very much blooming. and it is not that much into existence for Indian scenario, or because of the robotic arm. See, this is the robotic arm which is very much costly in printing the objects. So we have tried only the small objects. We have tried a very small objects called Mikotoy, and we have applied for the next level. So this is a tabletop printer what we have, which is used to find out, is to manufacture the miniature of any model. The very advantage of this 3D printing is to do some pilot study for any sort of tall buildings or huge equipments or machineries or whatever we are getting into. This is a small boat what we have made, which is actually 2.1 kilometers, but we have made a very small boat, and we have studied the hydrographic flow. That is, what is the speed, what can be the flow analysis can be made in this type of miniature boat, and this is interpreted with that of the prototype model. And this is 3D scanner where we can scan the product and we can develop into plan. The very advantage of using this 3D scanner is when we have a product but not the plan, then definitely we can get into this 3D scan. When we have a building but not the plan, when we have a face but not the what is it? The scanning elements of that face, then definitely we can go for this type of scanners, which really gives us the plan. So the product, from the product, we can go for getting the plan, and we can do any alterations with the plan. Especially if you are getting into a 5-star hotel product, by scanning that product, we can make any alterations in the 5-star hotel. If you want to add some rooms, or if you want to give some expansions, or if you want to give some projections, everything can be done by scanning the product and making the plan. So these types of scanners are very well utilized in medical industry. The surgeons, that is the plastic surgeons, are very well using this scanners in order to make some alterations, So this face can be even converted into a chitty robot after scanning this. So the product can be taken and that can be converted to plan, and any alterations can be made in the plan, and that can be again converted into a product. So again, these types of 3D scanners are very well used in automobile industry, where we scan the product, the car, and we make some alterations, whatever we need, whatever we dreamt about, then we can again convert that into a product. Yeah, this is the toy I was talking about, Miko toy, what we have produced in our lab. For this, we have used the transparent material, the PLA material, and we have manufactured this toy for good touch and bad touch example by using our 3D printer. And this is named as a Miko toy. We have named this as a Miko toy. Yeah. This is all about the case studies of derailment of trains. The government has announced in 2016 for a biggest hackathon and for the condition of railway tracks. So here we go with the case studies what we have done for. So these are some of the derailments what has been caused, all because of the improper alignment of the tracks in the railway system. All these accidents as you all see, all because of the derailment. Derailment is nothing but all because of the improper alignment of the tracks. So we have applied for the world biggest hackathon, that is Smart India Hackathon 2017, and we have developed a sleeper with a sensor, a very simple sensor. By using Raspberry Pi, we have generated the coding, and with this wooden platform, we have set the sensor over here. So you might have seen the people who work on the track alignment will be traveling with a very small movement track. So in that we have set the sensor, and this sensor will track you along with the station master, and the station master can very easily replicate that to the control unit, and the alignment can be done very much easily. So along with the people who are sitting in the track can use the sensor, within a minute or within the time efficient, we can track the alignment of the rails, and this will send to the control unit. And everything can be monitored by using the system. So we have tried a code by using Raspberry Pi. Yeah. Next is IoT. So when you talk about the latest technology or the thrust areas or the pressurized areas or the demands, we shouldn't forget about IoT. So when we talk about 3D printing, building information modeling, and other latest technology, IoT is the thing which feeds us the initial technology advancements. So here we go with the humidity measurement and shrinkage detector along with internet, that is IoT. So this is the cement mortar. So we have a ring over here. We have for a cylinder. We have placed all the sensors. This is the cement paste what you have put in the ring. So the humidity and the shrinkage of this particular cement mortar can be detected throughout. So when you want to study about the humidity and shrinkage, it doesn't happen within a time, within a day or within a week. So we need to observe that for days together. So we are get into this Internet of Things in order to predict the humidity and the shrinkage. So we have some different sensors like temperature rating sensor, humidity sensor, etc. And the shrinkage what I have measured is the autogeneous shrinkage, and this is how the testing is in progress. This is a ring and the testing is in progress. You can monitor that, and this is how the humidity has been observed for the days. And here is again an example of rapid wall making machine where you have proposed. The budget is given for this particular wall making machine. So you might have seen this in many of WhatsApp or in the article. So in order to finish the wall within a day or two, we are using this rapid wall making machine. So this is the coding what you have set up, or is the coding you have developed for this rapid wall making machine, and the budget is proposal is given for setting the budget. So other than this, what can be the interdisciplinary area for doing research in civil engineering? It is not only the materials. When you talk about composites, we get into mechanical department. So when we get into E&I, that is electronics and instrumentation and control engineering department, we get into structural health monitoring by using PST sensors. Automation in civil engineering. Automation is a very again booming area where we use robotics, where we go for automations in all types of construction, like plastering or wall making machine or whatever it is. We get into the automation, so that can be used or that can be focused as a part of interdisciplinary approach. Then wastewater treatment, recycle and reuse of wastewater. So even though we are working with the wastewater treatment, recycling and the reuse of wastewater from our olden days, from our early days and ancient days, we couldn't find a very better solution for this recycling, and always there is a demand for water, the potable water. So you can imagine what happens when there is a flood or when there is a heavy rain, especially in Chennai or Kerala. The water will be surrounded all over, all around, but we will never have the water to drink. That is what the pathetic situation what we have in case of floods, whether it is in Orissa or Kerala or Chennai, wherever you go. We are in demand of water. We are in demand of potable water, but still the research or still the area is vacant without the efficient or effective use of recycling of wastewater. Alkali activated concrete, development of coating is some sort of coating. So we usually go for some epoxy resins coating or rebars coating. So wrapping of concrete or coating of concrete is existing nowadays. So we can think in that particular area. And not only aligned with the engineering domains, we can also club our civil engineering materials or the concrete matrix into the medical field or Institute of Pharmacy, like self-healing concrete or corrosion inhibitors, sustainable geotechnical engineering using biochar and natural fiber. So anything which we use by means of natural fiber, by means of natural resources, then that definitely seems to be the sustainable growth or sustainable development. It is all that we should not degrade the natural resources, or else the usage of natural available materials really leads the way to the sustainable development or sustainable growth. And other simple innovations in civil engineering. When we talk about research areas, we have to club the innovations, because research plus innovation is the need of the hour, and that makes us to mesh up with the technology. And here we go with some sort of socio-environment sustainability areas like plastic roads, where we use the plastics grinder and we apply roads, and this has been implemented even in our colleges and even in our area, where we effectively dispose the plastics which cannot be decomposed. Green roof systems, eco-floating homes, vertical forming, modular construction, assets mapping, and drones in construction. So these are the areas where we are stepping into, but not very comfortable and confident to get into these aspects. We know what is vertical forming, we know what is drones in construction, modular construction, everything, but we are not that much confident enough to get into these types of pressurized areas. But when we are running only behind the problem, then definitely that makes the effective solution. It is not a solutions what we make, it is all about the effective solutions what you have to make. And that is why the innovations or the research has to be carried out in these sort of areas to be an effective researcher. So with this, I wind up throwing the glimpse of the recent areas or the pressurized areas where we can get into for research in the fields of civil engineering. Thank you.
Thank you, Ambika. Thank you for your wonderful session. Participants, if you have any queries, you can interact with the guest.
Thank you, ma'am. Participants, if you have any queries, kindly post it in the chat box. Ma'am, there is a query that is there any latest software related to geotechnical engineering?
Yeah, as I was related to construction engineering management, I was not much clear about geotechnical engineering. but Plaxis is very widely used for geotechnical engineering. Plaxis.
Okay, ma'am. Thank you, ma'am. Participants, if you have any other queries, you can kindly post it in the chat box.
Hope I have just thrown the a glimpse what we can do in trust areas. So many of you has been aware of all the technology. So just to give a glimpse of what has to be done and what we are working with, what is the feasibility of getting into these technology has been given for you. So I don't know how far it is very much useful. So it is all based upon your feedbacks and queries. I can improvise myself.
Ma'am, there is one more query
Yeah. So
that
have you observed any impact of microorganism in self-filling concrete with respect to structural stability? So as I was talking about, we can see the growth of the microorganisms inside the concrete when we go for the microscopic view, or else we can use the self-filling concrete only for the improvisation of the lifetime, not for the uh, structural. It can be very well used for structural durability than the stability. That is what I can say.
thank you, ma'am. Thank you so
I
much
hope I have
for
answered
providing
you.
us very informative session. Thank you so much, ma'am.
Thank you, Dr. Ambika. Thank you for accepting our invitation and your presentation. Very informative session. Thank you, Dr. Ambika.
Thank you, ma'am. Thank you once again for the opportunity given, and thank you all.
All the participants, you please fill your attendance link. Will be shared in the chat box. Tomorrow, you please join at the same time, 10:15. Thank you. Thank you all.